Okay, so when you have something like this, you're going to have an a over x minus 2, but we have an x squared inside our parentheses. This isn't x plus 7 squared, it's x squared plus 7. The thing above the denominator is always going to be 1 degree less than the denominator. So x minus 2 is a first degree. It's like a line. So a is just going to be a number. It's going to be a constant. But we have to put something over x squared plus 7. X squared plus 7 is a second degree. It's like a parabola. So bx plus c, exactly, because it could be like a line. So plus bx plus c. And if it was x squared plus 7 squared, I'd have to do plus dx plus e over x squared plus 7 squared. We could do so much algebra if we wanted to. It would be awesome. Okay, so now we're going to multiply everything by this denominator. So that's going to give me 3x plus 16 equals a times x squared plus 7 plus bx plus c times x minus 2. It's kind of nice because I only have two things in my denominator, two factors, so I've got to just take a times that factor and bx plus c times the other factor. So 3x plus 16 is equal to ax squared plus 7a, and then make sure you distribute this all the way through. This would be a bx squared plus cx minus 2bx minus 2c. Then we start putting together our equations. I don't have an x squared term here, but I do here. So it's really like there's a 0x squared there. So 0x squared must equal ax squared.
You just put 0.
Yep, because it's going to become 0 equals a plus b. Which means that a and b have to be opposite of each other. You know, it's the 3 and a negative 3 or something like that. And you'll start to see some shortcuts. Once you guys have done this a couple times, writing out all your x's, you'll skip some steps. Okay, so everything with x's in it, all of that has x's in it. So 3x equals cx minus 2bx. So that means 3 is equal to, I'm going to put my b first, so negative 2b plus c. And then do our constants. So 16 equals 7a minus 2c. And then that doesn't change any. 16 equals 7a minus 2c. Okay, so I would probably get rid of my c's. If I do substitution here, it really doesn't help me because there's c's in this equation. If I replace this b with an a, I still have an a and a c. If I replace this a with a b, I still have a b and a c. I still have two letters. So I'm going to multiply this middle equation by a positive 2. So that will give me 6 equals negative 4b plus 2c, and I'm going to add it to 16 equals 7a minus 2c. That cancels, and so I have 22. Oh, crud. I have a's and b's. Okay, but that's all right. So that's going to give me 7a minus 4b. Now, why is that okay? What am I going to use next?
The 0 equals a plus b.
Exactly. I'm going to use the fact that because of this, a equals negative b. So if I plug that into this equation, I get 22 equals 7 times negative b minus 4b. So 22, this is negative 7 minus 4, negative 11b. So b is negative 2. And if b is negative 2, that means a must be positive 2. Not too bad, is it?